So 373 here is just a little bit more fake malware. So the same thing, you disable Windows Defender. This picture shouldn't be there, I'll take it off, that was the old one. You download this thing called security.zip and install it, and you run bginfo64, because this is actually using a technique we'll talk about tomorrow called DIL injection. This is in fact this one here, DIL search order hijacking. I added the attack techniques that these malwares are using. So when you run this legitimate sysinfo tool called bginfo, it loads a DIL from this folder instead of from the right location. And that DIL is a proxy DIL that successfully imitates a real system DIL and injects malware into the machine. And what this malware does is it sends beacons. It sends network traffic to a command and control server, which is what bots do. When your machine is owned by a bot, it will send periodic packages back to the command and control server telling it, I'm under hostile control. And so, to detect that sort of thing, you want to catch network traffic from the endpoint, and that's here, Windows Network Packet Capture. This actually uses, there's a protocol analyzer built into Windows now, which in my tests doesn't run very well, but the people who run Velociraptor figured out how to run it correctly, which is more than I could do. And so this runs this thing. So you have to run this artifact twice. The first time you run it, it starts collecting traffic from the endpoint. And when you run it, it will return to you the path to the endpoint. It is an ETL file, which is some kind of Microsoft PCAP file. It tells you where it is, and the second time you run it is to stop the capture. You clear this start trace and you put in the trace file. So you have to start it and wait a minute, and then send it another request to stop the capture. But still, that is pretty awesome. You don't have to be anywhere near the endpoint. It could be in Brazil, and you'd be fine doing this from your remote controlling Velociraptor server. And then it will upload it, and it will convert it to a PCAP file. So right on your uploads, you'll have a PCAP-NG file. So you can just open that in Wireshark or any other normal packet capture analyzer. And when you do, you can see the network conversations. Now, the conversations to port 8000 are Velociraptor itself. That's what it uses. It connects to the server on port 8000, so it's going to capture those packets, but those are not malicious packets. In this case, it's the ones going to port 80 that are the beacons. So you just follow those, and you'll see a thing called getreport.php with an ID number. That's the beacon, and you can analyze it in Wireshark and find that it goes to this host, securityreport.samsclass.info, which is the URL of the command and control server. So now that you know the URL of the command and control server, you can now find it in the DNS cache. There's a DNS cache Velociraptor tool, Windows System DNS cache, and of course any machine that has the bot on it will keep making periodic DNS resolutions to that. So this would be one way to detect infected machines. If the bot is frequent, you'll frequently find this in the DNS cache. Of course, if it's rare, like only every 30 minutes or something, then this would only be in there for a couple of minutes after each bot transmission. Then you can find the program that is beaconing by making a Yara rule. This is what Yara rules look like. This is incredibly simple. You define a rule, you define a string, which is just security report, which is part of that command and control domain name, ASCII or wide, so you accept it in either 8-bit or 16-bit characters. And then the condition is just $S, which means if you find that, this rule triggers. It will just look for this string in any file. And now you can use the one I was accidentally trying to use about an hour ago. Windows Search Yara is a tool that will search the whole file system for a Yara match, but you have to upload a real Yara rule here with the upload button. So you have to make a text file containing this rule. You upload the rule, and then you can scan for all the exe files. There's a way to adjust that in the parameters, and it will find the file responsible for the beacons, and it will find that there's only one file. So now you know this executable is causing the beacons. And now, to find the persistence mechanism, what makes it repeat every 30 seconds or minute or whatever it's doing, you run sysmon. Your Windows machine may not already have sysmon installed. Yara will automatically install it and configure it, and then you can start seeing sysmon events just like we saw in Splunk earlier. So you run this one, sysinternal sysmon install from the Velociraptor server, and that will put sysmon on the endpoint. And then you launch this collector, event logs evtx, and you can tell it to just pick up the sysmon events, and you can restrict it to just the last 5 minutes, so there aren't too many of them. And when I did it that way, I only got 17 events, so it's really not too much data to look through. And you can just read the events here, and here is it launching the image, and it tells you the parent command line, just like what we saw in Splunk. The parent command line tells you what's going on. It's running service host schedule. So this is a Microsoft Windows scheduled task, which runs in the services to keep launching the beacon. So you have to harvest the scheduled tasks to see what's going on, and you can get them with Windows System Task Scheduler in Velociraptor. And when you do that, it will give you a list of all the scheduled tasks, and you can find the one that runs this security test.exe program. So it's very cool. And that's the second investigation using Velociraptor to go through.